Welcome to the CPD Low Emissivity Electrical Heated Glass, brought to you by Crystal Units. This CPD is accredited by the Royal Institute of British Architects. First, company introduction. Let's watch a short video about Crystal Units.
Crystal Units represents the many facets in today's demand for innovative glazing. Having successfully launched several manufacturing facilities located in North London, we are fully equipped to keep up with the ever-increasing demand for high-performance insulating glass units. With over 100 staff members, we strive to innovate the glazing industry. Operating for over 25 years, Crystal Units offer a wealth of expertise, with a creative team boasting impressive technical knowledge, establishing strong relationships with leading glazing specialists, system suppliers and contractors, working together to ensure the finished product is of the highest standard. In order to stay at the forefront of our industry, we continue to research, develop and invest in new plant and technology. One of our latest investments is a laser etching machine. This enables us to create self-heating glass to eliminate condensation in swimming pool areas or provide space heating in large glazed areas such as sliding and bifold doors. With 24-hour production and the capability to manufacture over 2,000 finished products per day on 3 automated production lines with a further 12 processing departments, the fully qualified Crystal Units production team are well equipped to keep up with demand. Supported by our dedicated office, sales and technical teams, Crystal Units are ready for any glass projects. As featured on Channel 4's Britain's Most Expensive Home, we are proud to have supplied our nuclear heated glass, eliminating condensation in the swimming pool and gym partition. Launched in 2016, CUIN insulating glass with suspended film technology is the thinnest, lightest and most thermally efficient glazing on the market. With all products certified by the British Standards Institution Kite Mark scheme, and with ISO 14001 environmental and ISO 9001 quality management accreditations, Crystal Units lead the way in safety, efficiency and environmental protection. And with Fleet Operator Recognition Scheme accreditation, we ensure best practice continues even after production. Our aim is to continue to manufacture glazing to the highest standards, introduce innovative ideas to the architectural glazing industry, transfer knowledge and awareness of glazing innovations to industry professionals, continue to innovate and develop environmentally friendly products. Glazing technology is forever advancing, and the only way to keep up is to be a step ahead. Here at Crystal Units, we pride ourselves on being the innovators of advanced glazing technology.
As a business, Crystal Units has been accredited with the prestigious Kite Mark licence in accordance with BSEN 1279, Glass in Building, Insulating Glass Units, ISO 9001-2015, Quality Management System, ISO 14001-2015, Environmental Management System for the full product range, Construction Products Regulation 2011, Attestation Level 1, which is the highest level conformity for fire-rated insulating glass units, compliant with the Fleet Operator Recognition Scheme and a member of the Glass and Glazing Federation, showing full commitment to professional workmanship aiming at a very high standard, accredited by the Contractors' Health and Safety Assessment Scheme. The content of today's CPD will cover introduction of electrically heated glass, further details of a low emissivity heated glass solution and how it works, specification considerations for low heated glass, compliance considerations, and project case studies to support the above learning. We hope that by completing this CPD, you'll achieve enhanced confidence on the use of low-E heated glass solutions with a greater understanding of what is electrically heated glass, how it's made, and what it can achieve, the specific performance features of low-E heated glass solutions, where low-E heated glass can be used and project benefits, compliance considerations, including regulations, standards and safety. What is electrically heated glass? Heated or radiant glass is generally an enhanced standard single pane or insulated glass units, using various busbar technologies to convey the electric current to heat the glass. Some technologies are patented and permit larger glass areas to be heated than others. Heated glass was first used on a wide scale in World War II in naval ships and on aircraft windshields to prevent them from frosting over in cold weather. It is still used in both for this purpose today. Heated glass has been used in architectural applications for the past 30 years to prevent condensation and provide radiant heat. As we know, condensation in buildings can have serious consequences to health and property values. The manufacturing process begins with the application of a microscopic tin dioxide coating to a pane of float glass. This coating is transparent and conducts electricity. Then, 2 bus bars are applied to the glass in parallel and to opposing edges on the same side of the glass pane. An electric current flows across the stannous oxide coating from one bus bar to the other. The electrical resistance of the coating produces heat energy, which radiates from the glass. The bus bars are connected to a power control unit that regulates the flow of electricity and thus the temperature of the glass. Laser edging allows the change of the electrical resistance of a module. In modern architectural projects, the heated glass is completely translucent. This technology uses a special metallic coating on the surface of the glass, invisible to the naked human eye. Electrically heated glass can achieve several performance benefits. For example, it eradicates condensation buildup in high humidity environments, such as gyms, spas, pools and museums. It prevents the buildup of and defrosts snow and ice. It balances temperatures throughout a room by removing the chill factor that's often felt when near large areas of glazing. It provides stylish, high-end alternatives to central heating and electric space heaters. Next, we will introduce a low emissivity heated glass solution and how it works. Low-E heated glass solution utilises the warming power of infrared radiation, delivering a sleek, stylish and efficient heating system. It not only adds a unique touch to a building, but also reduces the use of polluting fossil fuels when compared to traditional heating methods. In low-E heated glass, a low-E coating is applied to one surface of a glass pane that alters the thermal properties and the light transmission of the glass. This is used to help control the solar gain from the glazing and to increase the thermal efficiency of the building by reducing the window's U value. A low-E coating is made of various metallic oxides and so can be used to conduct electricity. This surface can either be built inside an insulating glass unit or laminated inside a single pane of glass. When electricity is passed over the surface of glass with a low-E coating, the glass emits radiant heat. Infrared radiation is emitted into the space, as well as warming the surface of the glass. This is felt on the skin much like the sun on a warm day. It warms surfaces rather than the atmosphere surrounding, meaning fewer cool spots and drafts are caused by moving air currents around a room. The heat level of each unit is controlled by near-invisible laser etching applied during manufacturing, in the form of invisible laser lines or hexagonal lattice in the glass. Low-E heated glass is designed to operate from a 230-volt mains input. A qualified electrician can wire the units after an installation using standard UK 230-volt mains power and a choice of thermostat. This gives an advantage over other heated glass technologies because they typically require a transformer and expensive installations in order to operate safely. The power output can be controlled from each panel by altering the electrical properties of the low-E coating. With some careful mathematics, the surface of the coating can be altered with high-powered laser etching to achieve the desired power level for each project application. There is a bespoke solution to fit every project and design requirement. Here is a basic wiring diagram from a project where low-E heated glass is specified. There are 4 panels of heated glazing, all wired in parallel to each other. It shows that low-E heated glazing can be wired into the mains via a thermostat or a building management system. It's compatible with all major home automation and BMS systems. Wires enter the unit through the secondary sealant and are soldered to the bus bars on the internal glass surface. These are hidden inside the sealant of the unit, which in turn is then hidden by the chosen framing system of the designer. Cables are run through the frame, away from the thermostat and power supply. Considerations for specification. Low-E heated glass improves the thermal comfort level for occupants in working and living environments, can help reduce construction costs and increase the performance of floor space. With low-E heated glass, a modern glass facade could be designed more economically without HVAC systems, such as radiators or fan coils, dependent on the environmental conditions. The indoor air temperature can be maintained to a lower level, which saves energy consumption. The auto-defrosting mechanism of low-E heated glass roofs prevents the safety risk of falling snow and ice, which is important especially in tall buildings. Low-E heated glass can replace normal heaters and provide a stylish element in the room with its discreet slimline appearance. It produces heat quickly, heating up a room in a short space of time. These glass heaters can be mounted on a wall, and most are designed to be waterproof, making them especially suitable for the bathroom or kitchen. These glass panel heaters can come in different RAL colours. They're a popular design choice in the hotel and leisure sector. Low-E heated glass is a great solution in pool and spa areas to keep large elevations of glass condensation free. There's a growing interest in the use of highly glazed facades in commercial buildings, which is linked with the concept of high-tech, modern design, daylighting and energy savings. Low-E heated glass can be integrated into the facade. Research shows that by maintaining the temperature of the glass surface, the indoor air temperature can be maintained to a lower level, saving around 8% of energy consumption per year for each air degree lowered in the room. It is also used for snow and frost removal for roof lights. It can be used in interior applications such as glass partitions that heat on both sides and give comfort or replace the main heating system. The spec of low-E heated glass is designed for the project in whatever configuration needed for the project performance required of the glass. Low-E heated glass can be installed into most glazing systems, such as double glazing units or single laminate panes. Glass thicknesses for insulated glazing units can range between 16 and 70 mm, and 10 to 14 mm for single glazing. Low-E heated glass can come in the maximum size of 3 by 2.4 metres. Larger sizes may be available on request. Light transmission is subject to glass spec. Typically, double glazing units can range between 20 to 68%, single glazing 20 to 70%. Low-E heated glass achieves ingress protection rating IP65, meaning the product has the highest level of dust protection and is able to withstand low-pressure water jets from all directions. Low-E heated glass can achieve 1 or 1.1 U value in standard DGU and 0.5 in DGU with thermally efficient glazing technology. Low-E heated glass units can be installed in structural glazing. The fixing and electrical details are designed bespoke for each installation. Each heated glass unit needs a coverage area at the head and base of the glass unit. Power and temperatures. Less power is required to prevent condensation than to warm a room. Low-E heated glass can be heated to a surface temperature of 20 to 80 degrees C. Due to the low thermal mass of glass, the heating is achieved rapidly. For example, by proprietary manufacturers' data, a surface temperature of 60 degrees C can typically be achieved in 20 minutes. For condensation removal. Condensation in buildings can have serious consequences to health and property values. When using low-E heated glass for condensation removal or draft elimination around glass, a power density of 150 to 250 watts per square metre is recommended. With this power density, the surface of the glass can be heated to the room temperature. For space heating. Where heated glass is being used as a sole heat source, a surface temperature of 40 to 55 degrees Celsius is commonly recommended by proprietary manufacturers. This can be achieved with a power density of approximately 350 to 500 watts per square metre. For snow load removal. If the low-E heated glass is being used for snow load removal, the glass should be installed so that the radiant panel is radiating to the external pane. A special control system is used which activates when the temperature is lower than 2 degrees. Large glass roofs can be divided into zones that can be controlled individually. Thermostat. The glass temperature can be controlled via a simple room thermostat. Low-E heated glass can be connected to a centralised control system, such as a building control system or home automation system, as any electrical heating system. It is compatible with most market-leading brands. Infrared heating uses less energy than conventional heating methods due to its high efficiency, meaning that using heated glazing potentially saves as much as 25% on an annual heating bill versus other electrical heating methods. There's less strain on a home boiler, potentially increasing its lifetime and reducing maintenance costs. Low-E heated glass requires no ongoing maintenance, as it contains no moving parts. Compliance. The Building Regulations Part L provides minimum requirements for many aspects of construction, including those relating to glass and glazing. The 2021 edition supports Part L of Schedule 1 to the Building Regulations 2010. This approved document took effect on 15th of June 2022 for use in England. Part L includes limiting U values for windows, roof windows and curtain walling for new and existing dwellings and non-dwellings. For notional building specification, the U-value target for windows is now 1.2 watts per square metre Kelvin for new dwellings. Building Regulations Part B bans the use of all combustible materials on the external wall of buildings over 11 metres tall for residential purposes. To be compliant, materials for such use should achieve a fire classification of A2S1 or A1, in accordance with BSEN 13501 Part 1, A1 being non-combustible and A2 being of limited combustibility. For further details on fire safety, refer to the Amendments to Approved Document B, published in June 2022, page 19, Table 10.1, and the Building and Fire Safety Guidance published on the RIBA website. Fire-rated glass and fire-rated systems are needed in residential and commercial projects to protect essential escape routes in the event of a fire, to protect stairwells, neighbouring buildings and access points. Fire-rated glass uses at least 2 panels of toughened glass. The cavity between each sheet of glass is filled with a transparent intumescent gel interlayer. In the event of a fire, the interlayer reacts to the heat and expands, creating an effective safety barrier from the radiant heat of a fire. Low-E heated glass technology can be incorporated with fire-rated glass to provide fire protection required by the building regulations. If in doubt, seek advice from the product manufacturer and specialist fire safety consultants. For glass specification, here are some key industry standards that can provide guidance for different project requirements. Most manufacturers can provide product certifications in accordance with such standards. For example, BSEN 1279 covers glass in building, insulating glass units, classifications, requirements, and test methods. BSEN 1096 covers glass in building, coated glass. BSEN 12150 covers glass in building, safety glazing, i.e. toughened glass. BSEN 1863 covers glass in building, heat strengthened glass. BSEN 14449 covers glass in building, laminated glass and laminated safety glass. BSEN 12600 covers glass in building, pendulum test. BSEN 60529 covers degrees of protection provided by enclosures for electrical equipment. BSEN 60335, Part 1, covers household and similar electrical appliances, safety, general requirements. IP ratings are used to classify the effectiveness of electrical enclosures in protecting the contained equipment from exposure to liquids and solids, including dirt, oil and water. The main material utilised in low-E heated glass can be demetallised, as typically happens with transparent conductive oxide and thin-film solar cell materials during the recycling process using a very simple method. This minimises waste and produces other marketable products. It should be noted that all IGUs must be dismantled prior to recycling to separate the spacer bar and the sealant. For the installation of IGUs, adhere to manufacturer's instructions and BS 8000 Part 7, Workmanship on Building Sites, Code of Practice for Glazing. Where work at height and access equipment is required for the site, care should be taken to provide safety measures such as scaffolding and PPE to prevent any person falling or being struck by a falling object, under the general principles of Regulation 9.2 of the CDM Regulations 2015. Low-E heated glass should be glazed by manufacturer's approved installers. Follow manufacturer's recommendation on the maintenance of the electrical system. Building Regulations Approved Document K4 covers protection against impact with glazing. It identifies critical locations for safety glass for all buildings. Glass manifestation makes the glass visible, preventing injury through collisions. It can also help enhance privacy and can be decorative. Guidance on this is covered by Building Regulations Approved Documents M and K5.2. Let's look at some project case studies. Claywood House, a new 5-bedroom low-carbon home, has been designed to meet the needs of a wheelchair-dependent client and to create spaces that allow her to live independently. The design celebrates the beautiful setting and builds into the landscape itself. The house is cut away to direct views across the garden and away from the former home, creating sheltered living spaces and establishing a clear entrance. A privately accessed guest annex is located to the south of the site. Claywood is the winner of British Homes Awards House of the Year 2022. The new building is fully accessible with a lift and provides facilities for the specialist care required by the client, including a physiotherapy pool, gym and carer's suite. The house incorporates a ground source heat pump, a 12 kilowatt photovoltaic array and a mechanical heat recovery ventilation system. The building envelope is extremely well insulated and airtight. Low-E heated glass is used in multiple areas, which helps create a highly sustainable new building. West Hampstead Home Pool. The project challenge was to prevent condensation on the glass panels surrounding the pool while also providing excellent thermal insulation on the external windows. Low-E heated glass partitions were supplied to internally separate the pool from the surrounding rooms. 17.5mm laminate glass was supplied to divide the spaces, ensuring no condensation could be allowed to form on glass surfaces. Low-E heated units were also supplied for the external windows and doors. The units ensured low U values of 1, whilst the heated pane ensured condensation was not able to form due to the high temperature differential between the external and internal atmosphere. Low-E heated glass units were supplied to Chester Zoo for a new enclosure, completed in autumn 2020. The challenge was the requirement of large units offering high visibility into a heated enclosure in all weather conditions. Low-E heated glass units achieving a U value of 1 and heating power of 200 watts per square metre were designed and supplied. This ensures minimal energy waste through the windows, but also meant that no condensation would be allowed to form on the internal panes in the winter months. Here's a project example of Low-E heated glass in use in an office environment. Here, Low-E heated glass in black is used as radiators in the office environment. It is usually available in a wide range of colours to suit the interior design. At the end of today's CPD, we hope you've achieved the understanding that Low-E heated glass is especially suitable for use as anti-condensers, a defrost mechanism for glass roofs, and as a heat source for building applications. Its radiant heat prevents convection and the cold wall effect, hence giving a pleasant and comfortable indoor environment, whilst helping to save money and energy. Thank you for watching this CPD. For project support, visit www.crystalunits.com for more information.